Good morning, ladies and gentlemen. Thank you for this opportunity given. Today I would like to present about our research. The title is Scrap Metal Reduction as the Effect of Combustor Upgrade in GTG 1.3 Muara Karang Power Plant. Before that, let me introduce my fellow partners. There are Fauzi, Leilan, Tania, Revina, Iman, Dimassetya, and also myself, Aulia, Rahmanissa. The outline of this presentation, we will discuss about the introduction, and then methodology, result and discussion, and also conclusion. Metal, as we know, is one of the most common used materials in industry. A waste that comes from it, usually called as scrap metals. Scrap metals, even though it's not listed as hazardous waste, it still has potential to pollute the surrounding environment, either land contamination or air pollution. Usually, scrap metal is stored or disposed in scrap yard or junkyard. This scrap yard or junkyard needs management or needs to be managed so that the scrap yard is not getting full, or to avoid a high accumulation in the scrap yard. That's why a proper management for scrap yard as well as the effort to reduce the metal generation is needed. This condition can also be seen in Muara Karang power plant, where the designated scrap yard is getting full nowadays. So while waiting for the auction process, which takes quite time to proceed, reducing metals or materials that goes to scrapyard is also important. In 2016, GTG 1.3 Muara Karang power plant was upgraded into Advanced Extendor Combustion System, which claimed to be more efficient in performance and increase its availability. So the following impact of it is extended maintenance interval, which causes less metal waste generated. So the objective of this study is to identify the reduction on scrap metals following the combustor upgrade compared to its condition before the upgrade was done. To conduct this study, we need two types of data. The first one is primary data, where we identify a list of components when combustor inspection is performed. After the identification, we check the materials in stock code to help locating them in the warehouse. After we got the materials in the warehouse, we will weighing them, and then put the data into data summary. And then the secondary data, we need to know about what type of maintenance performed in gas turbine in Muara Karang power plant. There are three types of maintenance. The first one is combustion inspection, which lasts for 9 days. And then the second one is hot gas path inspection, which lasts for 21 days. And then the third one is major inspection, which lasts for 45 days. In a brief, extender system is a combination of wear-resistant coatings, wear-resistant materials, enhanced clearances, and several mechanical design improvements that reduce combustion component wear. The maintenance interval is extended up to 32,000 equivalent operating hours, which increasing the availability until 4 years. The parts that improve in this advanced extender are enhanced thermal barrier coating, material changes, wear coating, hardening of surface in contact, and also clearance reduction. This table shows the maintenance duration before and after the combustor upgrade. in 8 years period, we can see that before the upgrade, we can see that every 8,000 hours, we will need to perform maintenance or combustor inspection, and then after that, in 24,000 hours, after 24,000 hours, we will perform a hot gas path inspection, and in 48 hours, we will perform a major inspection. And the total duration and the duration needed to perform this whole cycle of maintenance is 120 days, which is before the upgrade was done. And after the upgrade, we can dismiss the combustor inspection, which usually performed in 2 years respectively, and hot gas path inspection can be directly performed in 32,000 hours. And so the total duration for this maintenance in 8 years period is only 66 days. And this is the table that shows metal waste generation for one combustor inspection done. For one combustor inspection done, there is a potential to reduce the metal waste to a certain quantity. And then this table shows the reduction potential for each component that required replacement in combustor inspection. Okay, so by dismissing one combustor inspection, we can reduce about 2.26 ton metal waste for a year. And then using that, we can estimate that before the upgrade, we can produce 18 ton metal waste in 8 years period, and then after the upgrade, we only reduce 4.5 ton metal waste. So the reduction of the metal waste is 75%. The conclusion: the increased maintenance interval resulted to dismiss the combustion inspection, which usually performed every 8,000 hours, to directly perform hot gas path inspection in 32,000 hours and major inspection in 64,000 hours. The total maintenance duration required during 8 years period reduced from 120 days to 66 days. The less maintenance required leads to less metal waste generated, which mostly consists of replaceable spare parts, up to 2.26 ton for a year. In 8 years period, the combustor upgrade helped to reduce metal waste generation about 75%. I think that's from me. Thank you for your attention.